Okay, this entire chapter, of course, is based on your identities. And so what we're going to do is we're going to go through and we're going to work the odd problems on page 478 through 480 as a review. You will have the even problems done out for you in your packet of information. So we began with some of the very first basic problems on your, or identities on your review sheet. You've got your inverse identities and you've got your Pythagorean identities right at the beginning of section 7.1. Then you began to use certain identities to produce a certain result. So on page 478, beginning with number 11, it says use the given information to determine the trigonometric values in each case. So you start out with, it says the sine of theta is equal to 1/2. You are trying to find the cosecant of theta. Well, your inverse identities tell you that this is the inverse of this. So literally to get this one, all you have to do is flip it, and then you're done. That is number 11. If you go on to number 13, a little bit more complicated, and there's several ways that you can do these. If I do number 13, it says if the cosecant of theta is equal to 5/3, find the cosine. Now, you can use just your basic trig functions to do these, or you could use identities. But the cosecant is the inverse of the sine. So it is hypotenuse, if I'm standing here, hypotenuse over opposite. So then I would use Pythagorean theorem to find the third side. So I've got 25 minus 9, which is going to give me 16. So that's going to be a 4. So if I'm trying to find the cosine, cosine is adjacent over opposite, so it's 4/5. That is number 13. Then you move on to number 15, and they're telling you to simplify this using Pythagorean, any identities. But right here at the front, we used our Pythagorean identities the most. So number 15 starts out like this. The cosecant of x minus the cosine squared of x times the cosecant of x. And we're trying to simplify this or write it in terms of one trig function. So probably the very first thing I would do is I would convert everything to sines and cosines. So I have 1 over the sine of x minus the cosine squared of x times 1 over the sine of x. If you'll notice, they have a common denominator. So I have 1 over the cosine squared x is equal to the sine squared x, or just sine of x. On my Pythagorean identities, I have an identity that looks like this. Sine squared x plus cosine squared x equals 1. So 1 minus the cosine squared x is equal to the sine squared x. So this is equal to sine squared x over sine of x, which is equal to the sine of x. Okay, so that's number 15. Now that is the entire first section. The second section turned around and used these to verify the identity. So they didn't add any more to it. They continued to use your first set of identities, which is your inverse identities and your Pythagorean identities. And so when they say verify, it means make one side match up to the other side. So on number 17, I have that, and it's equal to the cosecant of theta minus the cotangent of theta squared. Now, my suggestion is to work on the right-hand side, because it really is the more complicated side. This is already in terms of sines and cosines. So when we do that, you would have to do FOIL on it. So we're going to do FOIL first. So I have the cosine squared theta minus 2 times the cosecant, and that's a cosecant, of theta times the cotangent of theta minus, actually it would be plus the cotangent squared theta. That is FOIL done out. Now I would convert everything to sines and cosines. So I have 1 over the sine squared theta minus 2 over the sine of theta times, now cotangent is equal to the cosine over the sine, and then you have the same thing here, but it's squared. Okay, so if I'm multiplying these two things together, I have sine squared on the bottom here. So I have a common denominator of sine squared theta. Then on the top I have 1 minus 2 times the cosine of theta plus, and that's supposed to be a cosine there, plus the cosine of squared theta. If I look at this factors, this is going to be a 1 minus the cosine of theta times 1 minus the cosine of theta over sine squared theta. Well, according to that theorem we just used, the sine squared theta plus the cosine squared theta, I can convert this bottom to cosines. So I have 1 minus the cosine of theta times 1 minus the cosine of theta on the top. And on the bottom, this factors into, well, it's 1 minus the cosine squared theta. I'll come back over here. So on the top, I have 1 minus the cosine of theta times 1 minus the cosine of theta. And on the bottom, that factors into the difference of squares. 1 minus the cosine of theta plus 1 plus the cosine of theta. Okay, so that and that are going to cancel out, leaving me with what I was trying to get to. In this same section, let's do number 19. Number 19 is the same. You're making one side match the other side. So I have the sine of, let's see, sine of 4x and the cosine of 4x over the sine squared of x. And this is equal to 1 minus the cotangent squared x. The more complicated side, of course, is going to be your left side. This is the difference of squares on the top. So you have the sine squared x plus cosine squared x times, and then when I have sine squared x minus cosine squared x, that's also the difference of squares. So that's sine of x plus cosine of x times sine of x minus cosine of x, and it is over sine squared x. If you continue to work this thing out, you've got, this is equal to 1, you know that, so that goes away. If you multiply those two things together, well actually I don't have to do that. If I don't do that out, and I leave it as the sine squared x minus the cosine squared x over the sine squared x. I'm going to have that over that, so I have the sine squared x over the sine squared x. I'm just giving them both the same denominator. because it is a common denominator. That is equal to 1, and that is equal to the cotangent. And you are where you need to be. So that matches that. Okay, so that's number 19. Okay, that finishes 7-2. Then when you move into 7-3, you begin to use the sum and difference identities, which you should have listed on all your identities. And this is where you break an angle into two angles that you know on your unit circle. So they're all going to be multiples of 30 or multiples of 45. And so on number 21, it's asking you to find the cosine of 195. Well, 195 is not on your unit circle, so you have to figure two things that are on your unit circle that either add up to that or you can subtract to get that. So I am using 135, which is on your unit circle, and 60, which is on your unit circle. Now you know the cosine of 135 is equal to a negative square root of 2 over 2, and the cosine of 60 is equal to 1/2. But we need more than that. We need, because of our identity, we also need the sine of 135 and the sine of 60. The sine of 135 is a positive square root of 2 over 2. And my sine at 60 is the square root of 3 over 2. So then I just began to plug in based on my identity, which says the cosine of 135 times the cosine of 60, opposite signs, so it's going to be minus the sine of 135 times the sine of 60. That's the way the identity plays out. So then I substitute in what I know. Negative square root of 2 over 2 times 1/2 minus the square root of 2 over 2 times the square root of 3 over 2. So this is going to give me negative square root of 2 over 4 minus square root of 6 over 4, which I can then turn around and write like that. And that's my final answer on that. Actually, let's see. I'm looking. That was number 20. I'm sorry. That was number 20, but that's done out for you, very similar. Okay, let's skip on down to number 23 in that same section, but this is written with radians rather than degrees. So I have the tangent of 11 pi over 12. The first thing I'm going to do is I'm going to convert this to degrees. So 11 pi over 12, and I'm going to multiply here, pi on the bottom, 180 on the top. My pi's are going to cancel out, so I have 11 times 180 divided by 12, and that's going to give me 165. Now, 165 has to be written in terms of your unit circle. So I would probably do, that's the same as 45 degrees plus 120 degrees, okay? Now, the tangent is a little bit different on the top, so I'm going to write it out here. The tangent of 45 degrees plus 120 is going to be equal to the tangent of 45 plus the tangent of 120 over 1 minus the tangent of 45 times the tangent of 120. Okay, and then I just substitute in. I know the tangent at 45 is the square root of 2 over 2. And the tangent at 120, if I do it out, is going to be negative square root of 3. So on the top, I have got actually, at 45 it's not square root of 2 over 2, it's 1. So I have got on the top, I've got a 1 plus a negative square root of 3. And on the bottom, I've got 1 minus 1 times a negative square root of 3. So, if you will, on the top I have 1 minus the square root of 3, and on the bottom I've got 1 plus the square root of 3. But I have to rationalize it and get the square root off the bottom. So I'm going to multiply both by 1 minus the square root of 3, the conjugate of the bottom, which is on the top is going to give me 1 minus 2 on the square root of 3 plus 3. On the bottom it's going to give me 1 minus 3. So right here I've got a 4 minus 2 on the square root of 3 over negative 2, but I'm going to divide the negative 2 into both of those, so it's a negative 2 plus the square root of 3, and that's number 23. That is section 7.3. Section 7.4 does your half angle identities, and all of it has dealt with that. So it's doing the same thing that you were doing, but this time you're using a half angle and the double angle. Those are the identities that you added in section 7.4. So looking at number, let's see, the first one in that section that you would have looked at would be like 27. Okay, and again, I've got the sine of 7 pi over 8. I would convert that because we're better at thinking in degrees than what we are radians. So on the bottom you have pi, on the top you have 180. So I have 7 times 180 divided by 8, and that's going to give me a 157.5. Now remember, it's half of something. So if I multiply that by 2, I can write this as the sine of 315 divided by 2. And then I'm going to use my half angle identity on it. So I am going to look at this, okay? It's going to be the sine of this, and I'm looking at this degree right here, and the sign in the second quadrant, which is where that would be, is positive. So I know it's positive square root of 1 minus the cosine of 315 divided by 2. So I just have to substitute in there what the cosine of 315 is, and it's actually going to be 1 minus, let's see, 315 is going to bring it around to the fourth quadrant, which means it's going to be positive. So I have 1 minus the square root of 2 over 2 divided by 2. Common denominator on the top. So that's 2 minus the square root of 2 over 2 divided by 2 over 1. I'm going to invert and multiply, which is going to leave me the square root of 2 minus the square root of 2 over 4. I can take the square root of 4, so I'm left with the square root of 2 minus the square root of 2. You have a square root underneath the square root, but on the bottom you have a 2, so there's no square root there, so you're good. So that is your answer to that, using the half angle identities.